Decoder module overview. It is the inverse of what I just described with the encoder module overview. The input to this is the MPEG-2 transport stream, which has the digital audio and digital video. The digital video, it goes through and gets decoded and gets outputted as the 422 YUV standard. The audio comes through and comes out either as an analog line out or a digital I2 SPCM. Encoder and decoder block diagrams. This is explaining at a higher level what I've explained at a detailed level from the previous slides. So coming into the encoder, you have a 16-bit digital video, and coming out of the decoder, you have a 16-bit digital video. I've been saying there's a 20-bit standard video format. That is true. There's 16 bits of video, and there's 4 bits of control and status. Same thing. Coming out of the encoder module and going to the decoder module, the transportation between that is this 8-bit parallel MPEG-2 transport stream. Audio coming in or out can be a digital I2S that we can just put onto the transport stream and pass through and pass out, or we can take analog in, pulse code modulate it, and put analog out on the decoder side. It's a 5 volts is required. We do offer a 3.3 out for if you need that on your main board. On the right hand side, you'll see the underneath side of the module, there's 2 mezzanine connectors. This is how it connects. So it's a daughter card that just sandwiches onto your main board. The 4 holes on the corners are screw holes, so you can tighten this down for a more robust solution. One last point I want to mention is the clock recovery for the encoder decoder sync are all on the decoder module already built in. Again, simplifying this design and getting you a product that you can get to time to market very quickly. Software API overview. All of this is in more detail in the programmer's manual, but you have control in the video of basically selecting the bit rate, selecting the GOP, selecting the into refresh, which is breaking the iframe into the P frames, selecting if you want an external clock, and from an audio standpoint, you can select if you want analog or digital, and also the frequency if it is analog that you want to sample at. The transport APIs, you can put in a network info table, program map table, or a service description table. We've purposely kept these commands simple, and the intelligence of what really goes on is all inside the module and incorporated, optimized for you. There are 3 major considerations for a video transmission system. 1 is the given bandwidth to communicate the data across. 2 is the quality, video resolution that you're looking for. And 3 is the latency that you desire. We have a profile selection, first thing you will do, that you state which of those are most important for you. Unfortunately, you can't have all 3 in this real world that we live in. So you first select a profile, then you fine-tune it with these above commands, and our intelligence of our system will optimize the best solution for best video quality going across the constraints that you have given us. Encoder development carrier board. Basically, the next 4 slides go over our development system that comes with our module, so you can immediately just hook up an HDSDI camera and an HDSDI display and and have a working model in your lab. The carrier boards do come. We offer schematics, layout files, BOMs, everything to help you design your main board that the development board falls into. This is actual physical picture of the carrier board. You can see where the module plugs in and the peripheral devices with it. Next slide we'll discuss the block diagram of it. Encoder carrier board block diagram. HDSDI video source comes in. Convert that to a 20-bit YUV 422, which goes in the encoder module. The audio line in, as well as the digital I2 audio in, goes directly to the connector to the module. Output of the module is an MPEG-2 transport stream that gets converted to a DVB ASI or DVB SPI for transmission over the coaxial. Also, we control everything via hyper terminal on a laptop PC. UART or USB out to UART on this is how it's controlled. There is an embedded ARM 9 CPU on this carrier board that you can use for programming it. We don't use it. It's there for your purpose for development purposes. The other side, the decoder development kit carrier board. Here's an actual photo of it. Again, you can see where the module plugs in and the peripherals that hook into it. Decoder carrier board block diagram. You have the DVB ASI or SPI coming in. That is converted back to an MPEG-2 transport stream, which is sent to the decoder module through the mezzanine connector. Hyperterminal UART, again, is the way we control this. Basically coming out is the HDSDI, the 20-bit video that gets converted back to an HDSDI out that goes to your display, and the audio line out and the I2S digital audio are just strict pass-through from the module. OEM development support, UART, configuration control and status interface. Again, as I mentioned, we use hyperterminal and very simple commands to set up the basic instructions on our encoder and decoder. SPI is available. It can be used with the onboard ARM9, onboard CPU again for OEM development, and then we have a JTAG interfaces, which is strictly for internal use. End-to-end setup. This is a photograph of a full development system. You supply an HDSDI source, you supply an HDSDI display, and the rest of it is what we deliver to you. Right out of the box, you hook it up, power it up, it works. Product availability. From a collateral standpoint, there's a data sheet and a programmer's guide, and also an HDK for the carrier boards that gives you schematics, BOMs, Gerber files. Very important, demo and evaluation kits are available today. Production of the modules, reference CDK, is available today. Everything is ready to go. Product roadmap, 1080p60 migration path. Migration to the PureVu CNW32XX module will be as simple as swapping the modules with minimal software changes. That is, there will be a 1080p60 version of this module that'll be a drop-in replacement for the 1080p30 module that you have now. It's basically the same form factor, same mezzanine connectors, same signal interfaces, same encoder decoder development boards. The difference between these two is there'll be a few additional registers that require minor software changes, but you're going to be getting 1080p60 versus 1080p30, and you'll get reduced power also. We have the product laid out today, and will be available in Q409, if not sooner. Part number ordering. The CNW22XX-CDK-CAMN is a Cayman development kit. It includes the modules, the carrier boards, the cables, everything but an HD source and an HDSDI display to get you up and running immediately. The production module part numbers are there, as well as if you need to order additional carrier boards, the part number is there.